Got myself a new bicycle to play with, a fat tire bike, and did some snowboarding and other stuff last week, so I didn't get much done. Kind of like this week, I'm stuck with just Saturday mornings to do anything. So, last Saturday morning I looked at this Tiger again, and this stubborn weird problem it has, and fired it up, and the thing worked perfectly. But after a while it started doing it again, kind of on and off. I can't find anything mechanical wrong on the board. And now this week I come here and note the bulb here when I switch the switch on. Oh, now it is acting up. See? It's been acting fine all day today. It would do just a little bright and then dim down. Now all of a sudden it's doing this again. Interesting. Well, that's a strange wrinkle to this take. My thoughts were, I used this unit to check the two electrolytics on the board here. This one's not even really on the schematic. I think it's on input somewhat. This is the only one of note, and this is actually in the feedback loop. Decouples to ground in the feedback loop. Attenuates a lot of the signal going to the feedback. Oh, now I'm splitting up my schematic here. Aged old schematic. It ties this feedback signal, see this resistor through here, but then it attenuates some of the feedback signal. See, I've always wondered exactly what this capacitor, why they needed a capacitor here. This could be my element of failure, because this cap, when I used the ESR meter on it, measured extremely low. It measured lower than it should be, in a higher range than what it measured. It measured 0.1 nano, so it's probably within the area of the meter is a dead short almost. So I'm thinking I was just going to change this cap out. These two caps are suspect too. One's got a lot of soot on it from when these resistors were burned up, which have been since replaced long ago. So at some point I want to go through these amps, rewire them, build new power supplies for them. These electrolytics are actually from Southwest Technical Products Company, but they're replacements. And as is the board. I replaced the I may have figured something out. Alright. At any rate, these are 35 years old, roughly. I replaced them when SWTPC was still in business. In the mate to this Tiger, it still has the original caps that are 40 years old, and they still work. And they are real long. This board barely clears the top on that unit. So at some point, I really want to get new caps for both units. Maybe rebuild the boards on both units too. In fact, I may be able to boil these boards down to a lug strip. I'd like to do that, rebuild all that, rewire the whole chassis, and replace anything like these electrolytics and this tantalum on the input. And anything else that's sketchy, do a full rebuild on them. But actually, I've got another pair of Tigers that were never fully built, and before I do anything, the long and short of it is I just want to get these guys patched up for now, and eventually come back to do a more thorough revamping of them. Much needed revamping. But I just want to get it working. And I also have the old Yamaha. And that actually works. But it has issues. And some of its issues are by design, unfortunately. The front panel has got an issue that's common to the unit. When I looked it up, I saw a lot about it. You get it open in one channel or the other on the front panel, and it's just the way it was made, pretty much. You start looking for it, it goes away. And the more you mess with it, the more it stays away, just from the motion, There's some kind of metal to metal in there that fails. Anywho, that's a whole other subject. The real issue with this Yamaha is I got some dissimilar heat in the you know, both power amp channels work, but one channel, the one driver and the one channel kind of gets too hot. Not into a failure point, but it's hotter than everything else, so it's kind of something's going on there. And this ESR meter is really what I've been waiting for to address that Yamaha, because the Yamaha's got a lot of electrolytics in the circuits. So I needed a way to quickly go through there and see if maybe I've got a leaky one or a... See, and that's nothing about this meter. It doesn't really show you leakage on electrolytics. So when you're looking at an ESR meter like this, it tells you one mode of failure, but it doesn't tell you every mode of failure. And it's not really going to show you that your cap is leaky. Although in this situation, I detected that this cap measured much lower than it really should. And I don't really see in the circuit that it's bridged by a low ohm resistor or anything crazy. So this is cool. I kind of think I might have found the problem. Found a problem. Okay, so watch the light this time now that it's fixed. Hopefully it'll work this time. That's what it should do. It should go on bright and then dim down. So the point on the Tiger that was broken, solder was broken, it's right between these two components. This is kind of an odd little loop here. This isn't ground, this is like an intermediate level. This is almost like a form of feedback going on through here. But it's not the global feedback. Global feedback loop is this. So this is kind of a little mystery here. Goes to the tie point between the drivers. Maybe John will have something to say about this circuit. At any rate, I was cracked right here. PC board's damaged, so these were just physical point-to-point, and the point-to-point cracked. It's probably, I don't think that's been a long-term thing. It probably happened on the bench here with me tossing this amp around. But let's look at the circuit again. I'm going to talk a little bit about the bias section. So this is what the bias section of the Tiger looks like. I'm going to redraw it a little more clear, simplified, and have a few words about that yet. Many of my new subscribers have come from John Audio Tech, his channel. But for those of you who aren't aware of that channel, I strongly recommend you go there. John Audio Tech. He's got a couple videos explaining in more detail than I'm going to go into about bias circuits and also about current mirrors. I'm going to go over this circuit real briefly. This is a simplified version of what's in the 0.01 Tiger over here. And this is just something I'm going to talk about, as you might find in some amps. Now, the bias, John calls it a bias spreader, which is a nice way to put it, because it kind of, the more voltage develops across this gap, this transistor allows, you know, it's like a constant voltage source almost. It's not constant though. But if this diode would stay cool, it would be kind of like a constant voltage source. What happens though is this diode is mounted on the heatsink with the output transistors. So it's getting hot along with the outputs, and it's actually dropping its voltage. Its forward characteristic voltage drops with temperature. And this diode is usually chosen carefully. And it just basically controls the circuit. You got a voltage divider and an adjustment on it. And these can all be varied in different ways, different manufacturers. Capacitor to get rid of any noise in the circuit. That's what's in the Tiger. A more simplified version of the circuit, and this would be used in an amplifier with less bias current. I said before that an amplifier need to be class AB in low distortion needs to have its bias maximized out. Say if these were output transistors, there's like 50 milliamps traveling through them at all times, even when there's no sound or anything going. And it's going from one rail to the other rail, you know, positive rail to the negative rail. That 50 milliamps current, so that's going to really heat everything up. It's a real critical current. It's not going to this output, it's going just straight through the amp. So you obviously can't go too high with it, or the amp will start going into thermal runaway. So from experience, they've pretty much gone with 50 milliamps. It's a real common number you'll find for bias on a Class AB2 amp. And at 50 milliamps, you're kind of on the hairy edge of what's going to make the amp overheat and what you can get away with. Now, an amp with a simpler bias circuit, the bias may not even be adjustable in most times when they give you a string of diodes. And if these were Darlington output transistors, you may have 4 diodes here. And if these were output transistors in general, you probably wouldn't have an adjustment on it. It'd probably just be like this. If these were drivers, then you may have the luxury of an adjustment in there. And they'll probably set around 25, 30 milliamps, give you a little leeway because it's not going to track very well. Although these diodes are again on the heatsink to make it track. Now this amplifier acts like it's supposed to act when I switch it on. Quick burst of light, and then it fades out real quick. I can turn the amp off and back on again. It's not going to flash because I haven't discharged the capacitors. They're holding enough charge to maintain the idle current. I couldn't find a capacitor. I wanted to replace the capacitor on the board here, and I couldn't find any. And I took a couple off of PC board. This is a recent manufacture. It's got that nasty ass lead-free solder. Holy, really nasty mess. Of course, I'm using it with a soldering iron that's been used with the other solder, so these aren't mixing too well, but it's coming off in crumbly, funky ways. You really need a little hotter iron for that stuff than what I've got here. I've got to improve my iron too. Really, the thermal regulated irons are worth having. So it lets you solder something big and small. So I got to move up to something with a regulation in it. Got a couple of high temperature caps. Normally wouldn't do this, but I don't really have what I need, so tough times, tough measures. I use whichever one of these caps fits the hole spacing correctly. Still a little tab of that stuff on it. Man, it just doesn't come off very well. Yuck. Nice smooth wires. So this capacitor tested suspicious. It didn't test high, it tested suspiciously low. So either it's an in-circuit thing or that cap may be leaking. And maybe now that it's working normally, it probably reformed itself. There shouldn't be a lot of voltage across it anyway. It's in the feedback loop. And I don't know, this whole, you basically got a global feedback loop. And this cap is part of a circuit that attenuates some of the level down to ground. So these meters are across the 0.01 ohm resistors off the emitters of the 2 output transistors. For that matter, I could have used the 0.39 ohm resistors on the collectors. The math would have been just, 4 times higher, 3.9 times higher. So idle current I want to be set to 50 milliamps of mutual conductance through the transistors. So I want to see 50 milliamps going through any one of those 4 resistors. I'm actually measuring the 0.1 on both sides. They should be right in concert with each other. They should never vary, unless your amplifier had a bad offset issue. And right now they're set right. What I need to do now, though, is play with this amplifier, crank it out for a while, go in the other room while this amp's cranking. And I'm going to actually cover this amp up with something small, hopefully not fireproof. And I'll let the amp deliberately get a little bit warm. And then I'm going to recheck these biases and probably turn it down a little bit. I want it to be 0.5, but I want to do it when it's warm. I don't want to just leave it cold and set it. Now, if the amplifier tracks bias really well, theoretically you could do this. But I at least have to recheck it when it's warm, if not readjust it.
But when I'm down, I just think these happy thoughts.
And I've seen amplifiers that overcompensate and amplifiers that undercompensate on bias with temperature. Where I had an amp, actually it was one of my favorite amps ever, but I gave it to my sister. But if you really jammed it hard and ran it hard, the bias would get so low that you started noticing a little more distortion. And of course the other amps the other way around, usually low power amps that aren't so well made, you know, tend to blow up because they overheat. And of course I've taken the dim bulb tester out of the circuit at this point, because that will change my bias setting.